So now we are talking about the connection between expectation maximization and variational inference. As you know, there is a difference between generative and discriminative machine learning, and we are focused on the clustering. An example could be clustering of stocks using agglomerative clustering, and the connection between k-means, which is deterministic algorithm, and expectation maximization. And you see, it's just an iterative procedure. For more complex data, we should use mixtures of Gaussians. So pi is the mixing of these different Gaussians. So there is so our solution could be using gradient-based optimization or expectation maximization. So as any case, we just maximize the likelihood, and we can see that in general we cannot find a closed form solution, so we should solve it iteratively using expectation maximization. So here we just compute gamma, and then you just put it here, and then we calculate the new mean, covariance, and mixing. An alternative view is using, for example, you have a latent variable as this is hidden variable. For example, in hidden Markov model, you have z. Z is hidden Markov model, hidden variable. We call it latent variable, and we are instead of maximizing p, we are interested in we want to maximize pz because this is an expectation maximization, and so we can derive the k-means as a particular limit of expectation maximization for Gaussian mixtures. So we want to formulate as an optimization of functional. The good thing is you can write p of x, this likelihood, as a sum of two terms, L and KL divergence, called back-Leibler divergence. And so maximizing like L is like minimizing KL divergence. KL divergence is how different those two distributions are. And then you go and you just use a multiplication of those distributions, and this is the solution. And so we just use the properties of Gaussians when you separate your state space into Z1 and Z2, and then we want to keep variance constant and see what happens to mu, to mean of that. And pi is mixing as well. So we use V-shard distribution because it is good for a prior, it's a prior, and for variational mixtures. So you separate your latent or hidden variable from the rest of the parameters that you have. So you can use such a factorization, and you see that you can work on. So this is the expectations step, because you're just you have R. You want to calculate mean and mixing, mean, and covariance. And the maximization step here is maximization step. You are going to maximize the other part, which is parameter part, and so it's an iterative procedure, and we use Gaussian V-short for prior of parameter distribution, and you see that's it. You go from expectation to maximization. You find mean and mixing and covariance, and you calculate R. And then you update it here and calculate a new mean and covariance and mixing. and then we compare Bayes with expectation maximization. There are multiple differences, and